We got a 2014 Nissan Altima. It's a 2.5 engine. This complaint is stalling. Let's see if I can get it to do it. As soon as you start up, it'll shut down. Oh, it's working fine now. We do got a check engine light. Let's see if I can get it to do it. When I first got it, it sat for about 3-4 minutes, and they drove it an hour away to get here. There you go. There you go. So that was, I'm gonna see if I can get it to do it one more time. Okay, awesome. So we got a pattern. What I'm gonna do, since we got a check engine light, pull the codes first, check for freeze frame data. The customer did send me a code that they got. I think it was P0011. Yeah. My first thought, logically, idle, throttle body. But let's see what the codes are first, see what the freeze frame data say, and then we'll do some basic inspections. Nissan's is not my strongest suit because the interpretation of data, sometimes I kind of get a little conflicted with the varying components, but we're gonna see what can happen. I don't work on these cars a whole lot. Let me get my scan tool. Before I do have the hood up, obviously. I'm gonna check for ruptures or rips in the intake tube or air intake hose. Make sure that's not loose, because if there's some type of issue with the mass airflow, it is definitely going to cause some problems, and that feels fine. Sometimes what will happen, people get oil changes, go to a lube spot, and they won't put that on properly after they check the oil, air filter, but that's fine. Did check the oil. The oil level was good. So, yep, let's go ahead and get the scan data. All right, so what we're gonna do, I'm gonna pull some information. Vehicle has 82,681 miles. This is very low. So I'm in the global portion here, and being that this is the global portion, it's not gonna have any bi-directional capabilities. It's just gonna simplify information for me, so I don't have to look into Nissan's conversion factors. So we got a cam A, camshaft position, timing over advance, system performance bank 1. So it's a P0011 like she sent me. So we got pending current and permanent. So this is definitely a problem. So it's not a throttle body position like I was thinking. Now, thinking about like Chevys, the actuators can fail. So we might have to go into the bi-directional portion. See if we can actuate the oil control valves for these actuators. I gotta see. Let's see what the freeze frame states. I don't think it's going to give me like that much information. It should be like a, wait, let's see here. So short-term fuel trims are going to be irrelevant. Now, we do know that it shuts down during startup. And it seemed like it might be like the oil control valve is stuck. Throttle position, irrelevant, time to start. So mainly if we had drivability problems, the air-fuel ratio sensor is going to be important. They're not important right now. And I'm not going to get the information I need. So camshaft, let's see here. Camshaft position, timing over advanced, system performance bank 1. What do I need to know? Code setting criteria for 1. So I need to get logged in Identifix and find out what causes P0011 from a code setting aspect, what the computer has to see and recognize. Let's go into the bidirectional portion. The code states that there's a gap between the target phase and the angle phase. So basically there's a desired versus actual angle discrepancy. So we're going to see about doing a cam angle test and an active test here. And being that the intake is supposed to be the one that's screwed up, let's go to the exhaust here and see if that works properly, and I can get an idea of what needs to happen, because Getting this Nissan system here. So I'm going to command, 1 degree. So I desire 1 degree, 2 degrees. We have reflection here. It's kind of meeting those expectations, trying to hold around 2 degrees cam angle. The duty cycle for the oil control solenoid, 34, 38. So it's working, sustaining that. 3, we're at 3 degrees, so it's reflective of it. So here's our desire, and here's our actual cam angle. So it's meeting those expectations. Go to intake, the one that has the problem. Here we go. So now we're at 0. Let me go up. Jumps right to 37. Maybe it enhances the duty cycle and then backs off of it to kind of try to sustain the angle, but it's not reflective. It's not changing the timing. Let's go over at 2. It's not reflective. So this is the PCM commanding it. There has no way of knowing that there's a duty cycle being administered to the solenoid unless it like happened to pull amp draw, but I don't think this has that capability. It's trying and it's not doing anything. So first things first, need to go to the solenoid itself and see what that solenoid is doing. I gotta make sure I'm on the right solenoid here. All right, the next thing to do, go right to the solenoid, see if that's working, do a visual inspection. Maybe have to pull it, see if there's any type of obstructions, depending on how accessible it is, see what we're dealing with. All right, if y'all know, I have Identifix, and I got the reading on this code. Some of the guys were saying as far as the location of the oil control valve, it's not going to be this one, because even though it's the intake, you would imagine the solenoid is going to be here, but this is not. One guy said it was the lock solenoid. So, and he said it was going to be the center solenoid down at the bottom. If I can see it, where is it at? Right there, that joker. It's gonna be that one right there. So what I'm gonna do, I think this is the correct one. I'm gonna pull, just get a bar and do the same test and just tap on it and see if it comes back to life. And if it do, then we'll start checking that one, pull that out. And they said it was interchangeable, so I can take that one and swap it with another one to back test the operation, or just simply pull it out and just see if it's defective. I can do an amp draw. I got a couple options I can put on my oscilloscope and pull the amps on it, but it's just no room down there to be able to do that. And I'm thinking the easiest way is likely just going to be to swap them or just pull it out, do a bench test and see if it changes anything. But I'm gonna hit it first, and if it starts coming to life, I'm gonna replace it. Just common sense. So I'm logged in back at the intake VTEC, or variable valve timing solenoid. And well, what I'm gonna do, I'm gonna control it again and see if I can tap on the solenoid and get it to reach that actual movement. I can look beyond that, go zoom in. But I think that's the center one they're talking about. And superficially it doesn't look that appealing, but if I can get down in there, swap that with the one here and see if it makes any type of change, I think that'll be the better option, because I thought it was that one, but that's the middle one I think they were referring to. So now I have the car running, I have the connectors disconnected. I was trying to figure out if I was on the appropriate one. This is the exhaust side here, because I'm in the bidirectional portion. If I deactivate the command state, because currently right now it wants to go to 94%. If I go down to 0, so it shuts off. I'm gonna go up 1, it wants to work, so it's at 94%. Okay, if I go down to 0, it deactivates. Oh, I'm keep going down. I need to go back up to 0. I'm at negative, so it deactivates. Now, if I go to this one, I have 12 volts. The test light illuminate. Let me get logged in for my intake. I should use a T-pin. I'm just being lazy here. So I'll check for 12 volts. I'm trying to command the intake side, but it's not doing anything. But I have 12 volts. It's not sending any type of pulse with low side, pulse with modulated signal for some strange reason. And I'm kind of thrown off from that. The exhaust side worked, but the intake side's not working. And this doesn't even show a percentage, so it just doesn't want to command it. So this is what it looks like on the intake side. I cleared the codes and it's not sending any percentage for command state for the solenoid. Now if I go to the exhaust, if I go up or down, look, it sends a command state. This makes me wonder if there's like PCM problems, or it's just a protocol issue, like it needs to see like backfeed for it to activate that one side. But why would it do that when I have both the exhaust and the intake disconnected? The computer should just command. But it was doing it before. Remember, like in the computer when it was in the car, it will command it 60-something% and then it will just shut back. It will be in and out. This might be a PCM related problem and not just a actuator. I mean, I could swap it around all day, but if the computer is determining to not provide any source of duty cycle to that solenoid, like the exhaust side, we're just dealing with a computer issue. I want to do one more thing. I can show you that there's both codes. Why would the code setting criteria be different for one over the other when they both perform the same duty? Yeah, so there's codes for the exhaust and the intake, but the exhaust work. Before I condemn a computer, I really need to be 100% certain that I'm testing this system properly, because the computer just only provides a service. It tells the components what to do. That's all it do. Go back to exhaust cam angle, and I'm gonna probably have to edit this out because I'll just keep going back and forward from exhaust to, look, go down negative, it goes to 94%. It's telling it to do something because it has to see an angle, and I'm thinking that it needs to see a change in that cam angle to back off to know how to perform. I guess it'll rather overshoot than undershoot. Again, we have the same codes because I disconnected the sensors. So I did disconnect the right one. Go back to intake. I'm going down, nothing. Go back up, nothing. I don't think we got a solenoid problem in this case. It just seemed like it might be a computer issue. I'm gonna check the resistance of the circuit, and what I'm gonna do, I'm just gonna backfeed it within its own self, in its own circuit, and that's what I mean. Make sure I don't know if you can see the multimeter well enough, but I'll read it out to you. So I'm just gonna, I don't even know what they're supposed to be, but I'm gonna go to the one that works first and just probing its own connector. So we got 262 k ohms, and let's see here. We're gonna have 262 k ohms, so they match. I'm not gonna break my neck over. The only other thing I'm gonna do, I'm gonna swap the exhaust and the intake and see if it makes a change. This glare off. So here's the bad one, the suspected bad one. Here's the good one. Now, this looks factory. I mean, it's got Aisin on there. Usually, like Honda uses these, and I guess Aisin's probably going to be Nissan's factory OEM part. It's like there's a weight difference though, but I don't know. I know they said something was replaced. Might have been this. Let's do a resistance test and see if there's anything different. These are interchangeable, so this is going to be the standard of what's proper. We have 8.5 ohms, 8.6 ohms. You know, ohms aren't a good determiner of a quality part, so 8.4. 8.3. Could just energize it, see if it actuates. I think it's worth a try. I'm gonna do a load test. This is pretty much just emulating the circuit. I'm gonna add power to the solenoids, and on the multimeter, I'm just gonna measure the amp draw. And again, this is just gonna be the standard of what's supposed to be put out with this exhaust one. So we got 1.47 amps. I'm not gonna worry about it being negative, just inverse the value. 1.47. Oh shit. Damn, that's shorted. Is it shorted? Did I do it right? Oh, there you go. It was hidden. So we got 151 amps. Okay, threw me off for a second. You gotta make sure your connections are right. So we got 147, so we're matching. Listen to the sound. Let's switch to the other one. Yeah, one of them sound a lot more confident than the other, and this has a lot more conviction. What we're gonna do, we're gonna swap them even though they have the same resistance, same amp draw. Let's swap them and see how they perform. So this is going on the exhaust side, which was working perfectly fine. This is going to the intake side, which was working poorly. Okay, we're swapped. Let's see what happens. Okay, it did act like it wanted to stall a little bit. But let's look at the data, see if anything changes. Let's see here. So we're gonna go to exhaust and see if we have those same controls. All right. So look at that. It's not working. So despite the same amp draw, despite the same resistance, the solenoid is just weak. Let's go to the intake side and see if it starts working. Maybe it needs to see a feedback circuit to operate. 12 volts go through the circuit, and get sent back to the low side as a value. Let's see what happens. Look at that. So I'm not sure why it's just saying 5 degrees, but we have actuation now. The solenoid is being commanded, and it's meeting expectations. And I wonder if the timing is off, because it's for some strange reason it's stuck at 5 degrees, but it's not going up any further. That's interesting. But we have a command now, though. That's the main thing. Let me see if I go negative, what will happen. So it doesn't change. That's weird. I wonder if anything if it has anything to do with the exhaust not actuating. Maybe it doesn't make any sense. I'm just throwing it out there, but it shouldn't. Maybe because the exhaust can't change. Maybe the intake's gonna change. But that's BS. I don't believe that. But I don't know. It's a possibility. Just like this threw me off, the fact that even though we disconnected both sensors, I was able to control the exhaust, but I couldn't do it with the intake. This may be the case, but we know 100% certain, despite those circumstances of it testing good amp wise and resistance, we need to put in a new solenoid and see if it continues to improve, if it improves or if it continues to stall. So let me quote them a solenoid and let's see what's in stock. Let me drop that in there. We'll come right back. All right, just got back from O'Reilly's, the part store. I have the new part here. Here's the old one. I went on ahead and pulled it out. Y'all know I frequently patronize O'Reilly's. Here's the part number. It's the Dorman product. It's 916-922. It was like $70 there. Not a bad price. What's about? Yeah, about $70. What we're gonna do, we're gonna check the waveforms out on our oscilloscope and see if there's a difference. Even though it had good resistance, it was compatible with the new one. It had, well, so with the working one, and it had good amps in comparison to a working one. So I'd imagine what we should see on our oscilloscope, we should see compatible numbers from the amp side, but I'm also going to check the voltage and see if there's anything with like the inductive spike. I'm gonna try my best to simulate a running condition or operating condition, but I'm not. I'll try to tap on it fast as I can, see if there's any differences. That's all I can do. And then we'll just evidently go from there. So I have 2 freestanding wires here. What I'll do, I'll hook up the old one the same fashion I am going to with the new one. And once I supply voltage with this wire here, we'll get operation. And then we'll just pretty much just look at the values or the waveforms from the amp clamp and look at the voltage value. All right, so we're gonna check the old one. I have my time base set up. I just got it on 1 volt. Let's see here. Let me see if I can move it over a little bit. So I got it on channel A is going to be the amp clamp. We should see about 1.5 volts. I'm sorry, 150 millivolts. That should equate to about 1.5 amps. That's what that should equate to, 1,500 milliamps, as we saw on a test meter. So on channel A, we should see 150 millivolts, 150 amp. I can't get it right. 150 millivolts to 1.5 amps. All right, let's test this old one. Let me turn it off, get it started. So channel B is going to be the voltage. That's when we see the transition from 12 volts and the voltage getting pulled down, and you see the current ramp starts to rise, and then you see the inductive spike here. I mean, it looks fine from a transition standpoint. Voltage get pulled down, the coil begin to energize and charge, our amps go up, stabilize, our release, and it holds, and you see the inductive spike occur, and you see the oscillation from the pintle. Nothing crazy. Let me see if I can. We do have a lot of inverse spikes, I guess, getting pulled down. So let me see if I can do more of a rapid succession. See what happens. There's that. So let's it looks normal. I'm just gonna be honest. I don't see anything out of the ordinary. It just sounds weak, and it just probably just doesn't work well under pressure. But I mean, the amps, I'd imagine, correct me if I'm wrong, would be reflective of its strength. It's not shorted. We have a nice inductive spike. It's a nice smooth transition. But let's check out the new one. I got that hooked up now. Same thing. The only thing I see different is that little hump. You know, and I guess that's from it moving so rapidly that it backpedals. And you see an inverse of the amp draw right there. And then it stabilizes. That's what I'm thinking. Same thing. You get some oscillation after I let off the power. And a good smooth transition to normal voltage, to the 12 volts that is reading. So, but you can hear how strong that sounds. What I want to do, I'm going to take some brake cleaner, put it inside of here, clean it out really good, and see if anything changes, just out of curiosity. So I got it cleaned up with brake cleaner and some compressed air. I sprayed brake cleaner down there and down inside of it. So let's see what happens. Hook it up the same way. It's not working anymore. Hold on. I know I got everything hooked up properly. I got 12 volts here, and everything's hooked up like it was before. It's nothing any different. Yeah, it's not working. Let me put the other one, new one, back on here. Wow. Yeah, putting brake cleaner in there, cleaning it out, actually shorted it out. Let me see if the resistance is the same. Okay, let's see. I get that there. So remember, I can't remember how many ohms it was making. That's my voltmeter. So okay, let's see what the value is. I can't remember the ohms. Seven ohms. It was 8 before. It's making 7 ohms, and it's shorted out. Let me try it again, because this works. This works. This works fine. Let's try the old one. See if it's still shorted. Yeah, still shorted. It's not doing anything. Even though it's showing that there's current being built up, it's only because of the resistance this unit produces. It's resistance isn't reliable. It's not. It's not. So we know this is broken. It's shorted out now. Even though I tried to clean it with brake cleaner, don't know what in the world happened. Yeah. Okay. Let me put a new part in there. We'll test crank it up, see if it stalls. Go from there. All right, we're back in the car. I'm gonna pull some codes, see if there's anything present. Focus. And if it is, we're just gonna clear those codes out and do a first startup. Okay, where's the? Okay, so the codes are present. Cool. All right, let's shut it down. Let's see if it stalls. No stalling. No stalling. It runs great. Shut it down. Cut it back on. No stalling again. Let's do it three more times. And it idles a lot higher too. It doesn't idle low. One more time. Okay, awesome. I think we're fixed. Yeah, we're good. Oh wow. That's a lot of power. That's a snappy throttle. I guess we can look at some data. Let's pull live data up. All signals. Oh, you know what we could do? Just go back to our testing function and see if we can do the same bidirectional test. So the cam angle there. So all those are fine. Fuel's low. Yeah, so we're good. We are in great shape. Let's go back. Let's just do that same test on the because we swapped it to the front, so it's technically the exhaust side now. Let's go to exhaust sign angle, escape. All right, let's make this happen. Probably the engine's not warmed up enough. It did say it needed to be around 80 to 100 degrees. That's fine. It's not in the proper range. Yeah, the coolant temperature's not within range. We'll try this anyway, see what happens. Yeah, it's not gonna work. Let me let it warm up. The car has reached an optimal temperature. Let me go back out. So we're going to the exhaust side. That's the one that we put the new part on. So we know the intake side works. We should be functioning properly on the exhaust side like brand new because it starts up excellent. Look at that. 1 degree. Let's see how it responds. We got a duty cycle. Cam angle has not changed. Let's go to 2. Why hasn't the cam angle changed? But we have a duty cycle. Let's go up to 3. There we go. So now it's starting to function. All right, there's a little slight delay. It's working though. That's the main thing. Let's go up to 4. It's making those accommodations. Let's go back down to 1 and see if it can hold that. Oh yeah. Yeah. Okay. Cool. We're in good shape. Car. It's got gas in. Let me take it on a test drive. Put some miles. How do you reset this thing here? All of these cars and this technology. Where in tarnation? Where's the oh there you go. So we're gonna do the trip reset. All right. I'll be back in a couple of miles. All right. I got 6 miles driven on it. Still runs perfect. Make sure there's no check engine light. Let's see if I can get this. Let's go back. Read codes. This car's, yep. Focus, no codes. So we're good. So like we're in good shape. That small test drive felt like a brand new used car. And it's crazy how something so, I don't want to say small, but that part, the size of it, can have such a major influence. But then again, you got a crank sensor. It's tiny and they'll cause the car to stall. But these vehicles nowadays have so many actuating components that enables or inhibit performance depending on the conditions that need to be met. And for that particular component, it is very integral. I mean, it causes cars to stall. The Chevys, those oil control valves are good to fail on 2.4 engines, those Ecotechs. But also, you could still have phaser problems. So the cam gear that phases, that can fail. You could have restrictions. You could have low oil. So you want to check your oil level first. Do you have timing chain rattle? There's a lot of things that could be going on that will cause that code. Because I've had that code happen and it wound up being a phaser on the Chevy. I've done a lot of those timing chains and phasers. I've got a couple videos up showing those replacement, but this is not a Chevy, but they can happen. Now, I guess a few key takeaways. The system in which this operates, I did not know that even though the oil control valves for the exhaust and the intake had different, I guess, fundamentals for functionality or for bidirectional capabilities. I thought maybe it needs some backfeed voltage. Maybe I should have hooked up a test bulb to it and see if I could have got it to command. But in hindsight, now I know if I get that code, just swap the solenoids and see if you have that command function on that bank that was inoperative. So now I know. And maybe it does need a backfeed, but it's just simple just to swap a solenoid versus putting a test light to it. But for demonstrating purposes and just for information, I don't know anybody else that has done this besides the source of information that I got on Identifix. I didn't do any investigative work besides when I got the car, when I turned this camera on, and when I got off and I started reading a little bit of information on some of the case studies. Anybody can get Identifix. It's the sources of service information for repair data. It provides me with wiring diagrams, labor times. It comprises of mechanics like me, many other people on there. When we get these cases, somebody has gone through this before. And there has been instances where I have not had cases, just like the hybrid vehicles, that I had to figure out on my own but as long as you got description and operation of the components, you have the capability of going through a process of deduction to see what needs to happen. And once we start knowing things, more familiarizing ourselves with the functionality of it, then we know how to better navigate through it. And it's the same diagnostic process. So with that said, I did learn something new every day. This job came an hour away, and same day it's going to get fixed and gone. So luckily, this I was thinking of, could it be a computer problem? I did a resistance test on the exhaust side, just backfed the pins with the test meter, had a resistance value, compared it with the other one, moved on to something else. So now we know how the logic works. Hope somebody can learn from our mistakes, and when it comes to pinpointing this particular problem, they'll be able to do such. But hey, if anything happened, if you have to come back, hopefully that dormant parts holds up. I've had them prematurely fail, but we're going to cross our fingers on this one, and hopefully you got a good batch or a good working unit, and it stays like this forever. But if anything happened, I'll definitely update. Hit that link, subscribe to the channel, stay informed, how to original work. See you next one.